Welcome back to this lesson. Now that we've covered several things about EC2, I want to focus on the service architecture in more detail. EC2 is one of the services you will use most often in AWS and is included in many exam questions. So, let's cover some high-level key takeaways first. We already know that EC2 instances are virtual machines. So this means it's an operating system plus an allocation of resources such as virtual CPU, memory, potentially some local storage, maybe some network storage, and access to other hardware such as graphics processing units and networking. These EC2 instances run on EC2 hosts, and these are physical service hardware that AWS manages, as I mentioned earlier. These hosts are either shared hosts or dedicated hosts. Shared hosts are hosts that are shared between different AWS customers. Therefore, you do not get ownership of the hardware, and you pay for individual instances based on the time you run them and the resources they have allocated. However, it is important to understand that all clients using shared hosts are isolated from each other. Therefore, there is no visibility of sharing. There is no interaction between different clients, even if you are using this same shared host. And shared hosts is the default option. With dedicated hosts, you are paying for the entire host but not for the instances running on it. It's yours, it's dedicated to your account, and you don't have to share it with any other customer. So, if you pay for a dedicated host, you pay for that entire host. You don't pay for any instances running on it, and you don't share it with other AWS customers. Now, EC2 is an availability zone resilience service. The reason for this is that the hosts themselves run within a single availability zone. So, if that availability zone fails, the hosts within that availability zone could fail, and any instance running on any host that fails will fail. Therefore, as a solution architect, you must assume that if an AZ or availability zone fails, at least some and probably all instances running within that availability zone will also fail or be greatly affected. Now let's see what this looks like visually. This is a simplification of the US East 1 region. I only have two AZ represented as AZA and AZB. And in AZA, I have represented that I have two subnets, subnetter and subnet B. Now, within each of these availability zones, there's an EC2 host. These EC2 hosts, they run within a single availability zone. I'm going to keep repeating this because it's critical that you know this in case you want to take any AWS certification exams. So, when you think of EC2 on the exam, keep thinking of it as an AZ resilience service. If they mention EC2 service in an exam question, see if you can locate the availability zone details because that might influence the correct answer. Now, on EC2 hosts we have some local hardware, logically CPU and memory. Also, they have some local storage called instance store. The instance store is temporary. If an instance is running on a particular host, depending on the instance type, you may be able to use this instance store. But if the instance moves from this host to another, that storage is lost. They also have two types of networks, storage networks and data networks. When instances are provisioned on a specific subnet within a VPC, what is really happening is that a primary elastic network interface is provisioned on a subnet, which is mapped to the physical hardware on the EC2 host. Remember, subnets are also in a specific availability zone. Instances can have multiple network interfaces, even on different subnets, as long as they are in the same availability zone. Everything about EC2 is centered on this architecture. The fact is that it runs in a specific availability zone. Now, EC2 can make use of remote storage. So, an EC2 host can connect to the Elastic Block Store or EBS. This also runs within a specific availability zone. So, the service running inside availability zone A is different from the one running inside availability zone B, and you cannot cross-zone them. EBS allows you to allocate volumes and persistent storage slice volumes. and these can be assigned to instances in the same availability zone. Again, it's another area where the availability zone matters. What I'm trying to do by keeping repeating the availability zone over and over again is to paint a picture of a service that is very dependent on the availability zone that it's running in. The host is in an availability zone. The network is per availability zone. Persistent storage is per availability zone. If an availability zone in AWS experiences your major issues, it will affect all of those things. Now, an instance runs on a specific host, and if you restart the instance, it will stay on that host. Instances stay on a host until one of two things happen. First, if the host fails or AWS takes it offline for maintenance for some reason. Or secondly, if an instance is stopped and then started, and that's different than just restarting. So, I'm focusing on stopping and then starting an instance. So, it's not the same as restarting. If any of those things happen, the instance will relocate to another host. But that host will also be in the same availability zone. Instances cannot natively move between availability zones. Everything about them, their hardware, networking, and storage are locked within a specific availability zone. Now, there are ways to perform the migration, but essentially it means taking the copy of an instance and creating a new one in a different availability zone. And I'll cover that later in this section. What you can never do is connect network interfaces or EBS storage located in one availability zone to an EC2 instance located in another availability zone. EC2 and EBS are availability zone services. So, to wrap up this class, an important question would be, what is EC2 for? What kind of situations could you use EC2 for? And this is equally valuable when you are evaluating a technical architecture or answering questions on the exam. So, EC2 is great when you have a need for traditional application processing and operating systems. So, if you have an application that needs to run on a certain operating system with a certain runtime, with a certain configuration, maybe your internal technical staff is used to that configuration, or maybe your vendor has a certain set of support requirements. EC2 is a perfect use case for this type of scenario. And it's also ideal for any long-running computing need. There are many other services within AWS that provide compute services, but many of these have runtime limits. So, you can't let these things run consistently for a year or two. With the C2, this service is designed to be persistent, with long-running compute requirements. So, if you have an application that runs constantly 24/7 365, and it has to run on a normal operating system, Linux or Windows, then EC2 is the default and obvious choice for this. Also, if you have any application which is server-style, EC2 is a perfect service for this. It is also ideal for monolithic application stack. So, if your monolithic application requires certain stack components, maybe a database or all runtime-based components, and especially if it needs to be running on a traditional operating system, EC2 should be the first thing you look at. These EC2 instances is also ideal for migrating application workloads. So, application workloads that are waiting for a traditional virtual machine or server-style environment, or if you're doing disaster recovery. For example, if you have existing legacy systems running on virtual servers, and you want to provision a disaster recovery environment, then EC2 is perfect for that. In general, EC2 tends to be the default compute service within AWS. So, with this detailed information, I want to make sure you're 100% sure with when and where I would select to use EC2. With that said, that's all I wanted to cover in this lesson. See you next time.